Alright, algebra students, so we come to our last topic in this unit, in Unit 5, and so think about where we've been so far. There's only 3 topics in this unit. The first thing we went over very quickly was x and y intercepts, and so that was pretty quick. That was a type into Desmos, find where the x-intercept is, find where the y-intercept is. And then we also, last week, looked at line of best fit, and so you've been typing in a lot of data and a lot of charts and typing in regression formula and making predictions. And so the last thing in this unit is actually called direct and inverse variation. Now, I'm not going to lie, I think this is one of the weirdest things that we learn all year long. And so today's notes might seem a little strange, like, wait, why would we ever do that? But on Wednesday of this week, or, well, 2 days from now, whenever you happen to be listening to this video, we're actually going to do some word problems of where we actually would apply this. So just hang on with me today, and we're going to talk about direct and inverse variation. So I'm going to go ahead and write that title at the top, direct and inverse variation. So just real quickly, the reason that this is even a thing is that over time, people who were looking for patterns in the world, mainly mathematicians, who saw patterns occur over and over again, began to give those patterns names. And so one of those patterns was that things directly vary, and then the other pattern that they saw was things inversely vary. And so this pattern happened so often that they gave them names. And so really we're just going to look at 2 patterns today. I need you to split up your page, though. We are going to make just this page into one big chart. And so we're actually going to need 1, 2, 3, 4, 5, 6, 7. We're going to need 7 different sections. And we're actually going to need our page split into thirds. We'll need 7 sections going across. So we're going to split. We need 3 columns. The first column actually doesn't need to be that big. So I'm just going to, if you've got a red line on your paper, I'm just going to sort of evenly keep this. This is just going to be sort of our titles over here. So go ahead and draw a line and leave a little section over here. We'll use this as the place where we write each section. And then take the rest of your space over here and split it into 2 even sections. Basically like that, all the way to the bottom. So we've got 3 sections here, and so our question, we're just going to use this first column for questions or titles. I'm not going to write anything there. We're going to use the second column for direct variation. All right, so D-I-R-E-C-T, variation. So we're going to look at examples of what that particular pattern looks like, and then we're going to use this last column for inverse variation. And we're going to use this column for what that looks like. So go ahead and split. So that's the first section that we need. So we need 6 more sections. So go ahead and draw that part off in your chart. And we're just going to section the rest of this off as we go. All right. So the first question, and again, we're going to put our questions and our titles over here. The first question is, well, what is it? What is direct variation? What is inverse variation? And so direct variation, the definition is this. It's a set of ordered pairs or a situation with some sort of data, and I'm not even going to write that in, or it's a situation with a constant value k, where k is equal to a constant y over x. Now, we're going to look at what that means here in just a second, but just get that definition down because we just need to know that this is the pattern. It's when a constant value of k is equal to y over x, and we're just using the letter k to identify a constant. Now, why we don't use C, I do not know. Just think K for constant. All right, so that's the definition of direct variation. Inverse is very similar. It's a set of ordered pairs or a situation. with a constant value. And the only thing that changes here is that k. The relationship between the x and the y is x times y for inverse. All right, and so again, this is just a pattern that occurs, and we're going to look and see what it actually looks like in actuality. But the only difference between direct variation is that there's a constant relationship, k is equal to y over x, and for inverse, k, that constant is x times y. And so we're going to see what that looks like here in just a second. So go ahead and split that off. That is one of the 6 sections that we're going to compare what direct and inverse variation looks like. All right. And so let's look at a set of data or a set of ordered pairs. And so the next question we're going to ask ourselves is, how do you test for it? All right, now, you might be given a set of ordered pairs as actual ordered pairs. It might come in a chart. It might be a list. You might just be given 2. But let's just say, and I'm going to zoom in a little bit so you can see a little better. There we go. How do you test for it? So let's say we're given some data, and let's say we've got, and I'm going to put this on the next line down here. Let's say we've got the number 1.5 and 7.5. And let's say we've also got the value 2 and 10. And let's say we've also got the ordered pair 1 and 5. Yeah. All right. Now, this could be in a chart, right? This could be an X and Y chart. And so we'd have like 1.5 across from 7.5 and 2 across from 10 and 1 across from 5. However you're given this set of numbers or these set of ordered pairs, notice that the relationship between these, and again, we're thinking about direct variation here, is we're going to check y divided by x for all data. Okay, and that's going to give us our k value. So notice here the relationship, and it's really easy to see here, right? But it's really easy to see that if you took 5 over 1, so this is my, again, this is my x and my y, my x and my y, my x and my y. If I took all of my y's, 5, and put them over 1, and it, like I said, it's easier to see on these two. 10 divided by 2. And even, and you may have to use a calculator for this, but 7.5 divided by 1.5, if you check the y over the x for all these data, they all come out to be the same thing. It's our k value. And so the constant, and this is why we call it a constant, is because it comes out to be the same thing. The constant value, 7.5 over 1.5, and 10 divided by 2, and 5 divided by 1, all comes out to be 5. And so our k value, there's a constant value between the relationship between all of these numbers, right? They all happen to be that if you took the y value and divided by the x value, you get 5. And so that's what it means to directly vary. There's this constant relationship between all of this data, and it's 5. It's 5. All right. And so actually, in the spirit of this example, I'm going to go ahead and go to the next. I'm going to go ahead and split this off. We'll come back to inverse variation here in just a second. But let's just think about direct for just a second. Let's think about what this means. Okay, so if this is true, if there's this same relationship, this constant value between all of the data, then there must be an equation. So the next question we're going to ask is, what is the equation? All right. And the equation form of a direct variation is it's always in this form. It's always going to be y is equal to kx. Because if you will look at this data that you're given, well, how do we get from the x value to the y value? There's another relationship here. It's if I took the x value and multiplied it by 5, I would get the y value. That's where this constant comes in, right? 2 times 5 is 10. 1 times 5 is 5. It's another way of looking at how these data, how these numbers are related to each other. So the equation is all for direct variation is always going to be y is equal to some number, whatever that constant is, whatever that constant relationship between the y over the x is, then the equation is going to be y over x. So for this particular example that we're doing right here, this equation, it's not going to be 5 every time. But for this particular example, the equation is going to be y is equal to 5x. We just take that constant and put it in front of the x. And you can check yourself, right? Because again, if you take every x value and multiply it by 5, you're going to get the y value. 1.5 times 5 is 7.5. 2 times 5 is 10. 1 times 5 is 5. And so our equation for this particular relationship, this would be the direct variation equation. All right. So now let's go back and let's do the inverse variation example. So I'm going to be given another set of points. So let's do 2, 7.5, and then 3, 5, and then 5, 3. All right, now notice that there is no way that this can be direct variation, right? Because if I tried to test for it, remember, this is how do we test for it? The test for direct is always take your y's and divide them by x's. And if that's true, if you get the same number over and over again, it's direct variation. Now, if we tried to do the same thing here, 3 divided by 5 and 5 divided by 3 are definitely not going to be the same, right? There's no constant here that is y over x. Well, that's because this is not direct, this is inverse. And so what is the relationship between, again, it's just a pattern that happens over and over again. What is the relationship between inverse variation? Well, there's a constant, but it's not y over x anymore. It's x times y. It's just the ordered pairs multiplied together. And so for inverse variation, to find out if it is inverse variation or not, we're going to check all the xy pairs. We're just going to multiply the numbers together for all data. All right, and so we notice here, and we'll do that. So we're just going to take 2 times 7.5, and we're going to take 3 times 5, and we're going to take 5 times 3. And if those all come out to be the same number, then it is inverse variation. That's the pattern that happens for inverse variation. And that's our k value, that's our constant. And so if we use Desmos or use a calculator, 2 times 7.5 is equal to 3 times 5, which is equal to 5 times 3, because all of those things are equal to 15. And 15, is our constant for this inverse variation. So that's the only difference between the two, is that here's the pattern. There's this pattern that happens for direct variation, where it is y over x, and the pattern that happens for inverse variation is that when you multiply all of the data points together, the x's and the y's, you get the same number. All right, so now let's look at the equation. The equation looks a little different. For inverse variation, the equation is always going to be y is equal to k over x. So they're almost opposites. You divide to get the k value for direct, and then it's a multiplication equation. For inverse variation, there's a multiplication relationship between the data points, but it's a division equation. And actually, and we can test it out, so the equation that relates these data points together is y is equal to, our k value we came up with was 15 over x. And you can check and make sure that that's true. If you take 15 and divide it by any of these x values, 15 divided by 2 is 7.5. 15 divided by 3 is 5. 15 divided by 5 is 3. And that's the relationship between your data points. So again, these boxes are going to be important, because this is how you find that constant value from your data. Here you divide y over x and get a constant. Here you multiply y times x and get a constant. And then you write an equation by doing sort of the opposite of that. So you plug in your constant in a multiplication equation, y is equal to 5x, and then here you take that constant and you divide by the x to get the y value. So that is the form that the equations will take. And so, I mean, these are just two examples. Your constant is not always going to be 5, nor will it always be 15. You could have a bunch of different, so we're just going to write down some examples of what these might look like. So examples, and we'll just leave 3 lines for this. So some examples of direct variation, if you're asked to identify whether something is direct or not. As far as an equation goes, it might be something like y is equal to 2x. That would be a direct variation equation. It might be y is equal to negative 3x. That's a constant times the x value, gives you the y value. It might be a fraction or decimal, so you could have y is equal to 0.7x. That would be direct variation. Y is equal to 3/2 x. That would be direct variation. Sometimes even, and again, it's because of the constant, you might even have something that looks like this. Y over x is equal to 2. Because if you were to solve this for y, to get y by itself, you'd have to multiply by x. And if you solved it for y, it would be y is equal to 2x, which is a direct variation equation. So it may look a little funny sometimes, but that's because of this relationship, this y over x relationship, and we could just solve it for y. So again, just in general, these are what the equations are going to look like. Now, inverse variation will always take this form. So you could have, I don't know, if your constant was -2, you could have -2 over x. It's always going to look like some number over x for inverse variation. You might have y is equal to 6 over x. It could be a decimal or a fraction, so y is equal to 0.9 over x would be inverse variation. You could have something as silly as y is equal to pi over x, as long as it's some constant number over your x value. And again, it might look like the equation might not be solved for y. So if it were something like x times y is equal to 5, then again, we could just solve that for y and divide by x on each side, and you would still get y is equal to 5 over x. It just wouldn't be written like that originally. It would be based off of how you found the constant. Now, I don't have Desmos to bring up, but you could check me on this. If you type any of these equations into Desmos to graph them, in general, the graph of a direct variation equation, and I'll just draw a little sketch here, because they're all going to look slightly different. But in general, what you need to know about the graph of, again, we're direct variation here, right? We're still in the direct variation column. All of these equations, if you were just to take a second and go and type all of this, just type in y is equal to 2x, y is equal to -3x, y is equal to 0.7x, y is equal to 3/2 x, you would notice that all of these equations would be lines that go through at varying slopes, and sometimes even negative slopes, but they would all go through, they would be straight lines going through the point 0, 0. So a direct variation graph will always be a line through the point 0, 0. So you are going to be asked to identify, like, is this the graph of direct variation? And just know that if you graphed all of these equations, they would all be lines that go through 0, 0. You could check me on that. Likewise, inverse variation always has a constant graph shape. And again, it might move around a little bit, and it might stretch out or change direction a little bit. But in general, if you were to go type, and you might want to do that, you might want to pause the video and go and just check this out for yourself. If you type y is equal to any constant over x, it gives you kind of a funny looking graph. They all look like this. They're sort of like half moon shapes in opposite quadrants. So you may notice that there's one here and one here, or they could switch, and these lines could be here and here. So it could be like a half moon shape here and a half moon shape here. Those are the shapes that inverse variation always takes. So it's sort of like, again, like this half moon sort of C shape in opposite quadrants. And so again, you might want to take a second and go type some of those in just to convince yourself, but you will be asked to differentiate between a direct variation and inverse variation. Inverse variation always looks like this. Direct variation always is a line through 0, 0. This one doesn't have common points, and it definitely doesn't go through 0, 0, but it should look like that. Inverse variation will always look like this. All right? And so the last thing that we have to write down, and so your assignments will ask you to practice all these things. It'll ask you, your first assignment will ask you to check for a direct or inverse variation relationship by checking what is the relationship between values of your points. Do you have this constant y over x relationship, or do you have to multiply them to get a constant number? It'll ask you to write the equation. And so remember that would be multiplication for direct, and use this example for inverse. And then if you're doing the IXL, the last piece is, let's do checking and writing equation. Checking and writing equation. All right, and so it might give you a problem of something like this. Actually, I don't even know if we needed to write checking, because it's going to tell you what kind of variation it is. So let's just do this problem. In direct variation, if y equals 15 and x equals 5, write a direct variation equation that shows this relationship. All right, and so yeah, we really didn't have to do any checking here. We're really just writing an equation here. And so for direct variation, we're just going to look at and say, okay, how would we do this? If we're given a y and an x value, then we look up at how do we test for it? And so to find our constant, it's always y over x. So that's all we're going to do here first, is we're going to check for our constant, and we're going to say, okay, it's y, which is 15, over x, which is 5, and 15 divided by 5 is 3. So that means our constant is 3, and then we're going to use that information to write our equation. Well, if our constant is 3, the equation, the relationship here, so my equation is y is equal to 3x. And that makes sense, right? If x is 5 and we multiply it by 3, we do get our y is equal to 15. And so that would be our equation. And that would be in the IXL assignment, that would be what you type in, y is equal to 3x. So we're going to do a similar one with inverse. In inverse variation, if y equals 3 and x equals 8, write an inverse variation equation. I'm just going to put EQ for equation, if that's okay with y'all. That shows this relationship. All right, and so our k value, our constant value here. Now again, we have to remember what's the relationship in inverse variation. It's that x times y gives me my constant, right? There's this constant, like if I multiply all my x and y values together, I get the same number. And so here, I'm just going to multiply my x and y values. It doesn't matter if you do 3 times 8 or 8 times 3. 3 times 8, my constant here is going to be 24. And then I use my general formula. What does the equation look like? My constant over x. And so when I write my equation, it's going to be y is equal to 24 over x, which makes sense because if I do 24 divided by my x value 8, I do get 3. 24 divided by 8 is 3. And this would be the answer that you type in to IXL. So we're just practicing finding these. Again, these are just patterns that happen over and over again. And we're going to look in our next video at what are some real world situations where direct variation shows up and where does inverse variation show up. Again, it just happened so often that they called them names. And so right now it may just seem like a bunch of numbers and dividing and multiplying and equations and why am I doing this? But again, we're going to practice actually writing the equations and finding the patterns first with the numbers, and then we'll do some word problems in a couple of days. So make sure you have all this written down. It's going to be really helpful to have everything here in these two columns to look at as you're practicing direct and inverse variation.